Hi everyone. Today I'm going to present on the project on function of GeoPlaster, finishing with fire protection for construction work. This project is compliant with SDG 9 and SDG 11. The inventors of the project are me, Associate Professor Dr. Rafiza, Associate Professor Dr. Zarina, Professor T.S. Dr. Muhammad Mustafa, Dr. Rosnita, T.S. Dr. S.K. Muiz, and I.R. Monzani. So let me introduce about the traditional plaster. Traditional plaster finish look good, but lack final proving and require additional coating, complicating construction and increasing cost. GeoPlaster offer a smart alternative, provide a durable without any extra fire-resistant coating. It also enhance safety, especially as a fire barrier. GeoPlaster can be applied directly on the concrete surface, eliminating the requirement for carry out the fire-resistant coating. Now, the problem statement of this project, and we know that the traditional plaster require an additional layer of fire-resistant coating for fire protection, and it also require steel label since it involves numerous layers, each of which must dry properly before the next layer is applied. The material and labor associated with traditional plastering are offer more expensive. So the novelty of this project, of this invention, is GeoPlaster can be applied directly on the concrete surface without any additional fire-resistant coating. As we can see, the traditional plaster and the geopolymer plaster, the differences. And the GeoPlaster is very easy to use as it's using one part geopolymer method, which is just adding water that can be applied directly. Geopolymer plaster as intermittent coating. Geopolymer plaster enables numerous advantages, especially in construction field, as meaning the need for a second layer for fire-resistant coating directly applied on the surface of concrete without second layer of fire resistant, act as a fire barrier, providing passive fire protection and enhanced safety. The advantages of this project or this invention: dual functionality, combine high quality finishes and fire resistant in a single product, enhance fire protection, comply with industry standard for fire resistant, offering essential time and during emergency. No additional coating, conserve time and money by minimizing the requirement for an additional fire resistant layer. Smooth, durable finish, applicable in several texture or finishes ranging from conventional smooth to decorative design. This is the manufacturing process. We're using the GGPS with fly ash, add with sodium metasilicate, sodium hydroxide in solid form, and we'll add with water, just water, and will become the geopolymer plast and geopolymer plaster. Geopolymer plast, geopolymer caster will cast in 50 mm more to carry out the experiment, to carry out the testing. This is the GeoPlaster mixture and the geopolymer mixture coated on the concrete surface. The testing we have carried out is water absorption, compressive strength, and adhesive strength, as are the analysis, engine S, and strength loss. As we see the water absorption, the water to binder ratio of 0.34 have the lowest, which is 14.17% at 7 days and 12.8% at 28 days. For compressive strength, it also found out that water to binder ratio of 0.34 have the highest water compressive strength, which is 27.15 megapascal at 7 days and 36.65 megapascal at 28 days. And this is the GeoPlaster applied on the surface after exposed to heat. The fire exposure at 800 degrees Celsius for 2 hours. This is the video on the exposure to heat, as we see that the heat is directly applied to the surface of the GeoPlaster. Now, we are also carry out testing using engine X. This is the before engine exposure to engine S using the engine S as UK, Oxford UK, and the right hand side we can see the fire exposure as it has exposure to heat at 800 degrees Celsius. As we can see, left hand side before exposure to heat and right hand side after exposure to heat, there's no crack detected. The size coating also unchanged, and the geopolymer expand, but the size still remain the same. As we also carry out the strength loss testing, as we also found out that 0.35 water to binder ratio have the strength loss, and the adhesion strength, also we found out that 0.34 ratio for water binder ratio have the highest strength, adhesive strength, which is 17.10 megapascal for 7 days and 19.63 megapascal for 28 days. And this is the SRD analysis using the engine S machine at UK, Oxford, UK. And we found out that the top layer, which is the GeoPlaster, have the possible break peak, which has a reaction, have proved that there is a reaction that can bind on the concrete surface. And this is the potential commercialization, as we know that the GeoPlaster premix plaster can be used by just adding water. Easy to use by simply adding clean water into the premix plaster. And here have the two-in-one function, which is wall finishing and also the fire protection, as it's very cheaper as it's using waste material or recycled material. And this is a list of publications that we have been published for this invention. And this is a list of patents that we have been also obtained or filled out for this invention. And this is the list of grants that we have been obtained. And we have obtained 2 grants for this invention. First is about the Fundamental Research Grant Scheme, FRGS. And the second is about the ISPF use of the ISIS neutron amnion source at UK. And another one we have been achieved is that our team from University Malaysia Place had achieved a significant milestone by testing a geopolymer coating material and engine as the specialized engineering being line at IC Neuron. And we also get the result and also the first team that have been going to engine S to carry out the testing about the geopolymer. And we would like to say special thank you to ISIS Neutron and your resources for providing us the engine S machine for carry out the testing. And also we want to say thank you to MDC Concrete for providing the raw material, which is fly ash and the GGPS. That's all from me today. Thank you.